Here is another related rate problem. So suppose that a snowball melts so that its surface area decreases at a rate of 4 centimeters square per minute. And we want to find the rate at which the diameter decreases when the diameter is 11 centimeter. All right, so suppose we have a snowball. So let's imagine a circle in three-dimensional space. So perhaps something like this. So it won't probably be the best picture, but I just want to give you an idea what this looks like. So let's suppose that's the snowball. So we need to know what is the surface area of a sphere. So the surface area of a sphere, it's going to be, let's S stands for surface area, is 4 pi r squared. Now the formula involves r, but the information we're given is in diameter and the surface area. So since the diameter, let's call it d, is 11, and we want to bring in d into this formula, so we want to replace r in terms of d. So we know that from algebra, diameter of a shape, a circle, is going to be 2 times r, which means r, the radius, is going to be the diameter over 2. So that's what I can substitute in here to express surface area in terms of the diameter. So then our surface area, S, will simply becomes 4 pi d over 2 squared, which will simplify to 4 pi times d squared over 4. Then here freely we can cancel out 4. We have pi d squared is the surface area. Well, let's write down what is given to us. So we know that it is given in the problem that the surface area, the rate right here, so let's call it ds dt, the rate of the surface area is decreasing, meaning negative. So negative 4 centimeters square per minute. So every time it says decreasing, then you know that's negative quantity. And we're also given that the diameter d happens to be 11 centimeter. And what is unknown to us, it's going to be what is the rate at which the diameter is decreasing. So we're looking for dd dt. That's what we're looking for, the rate at which the diameter is decreasing. Well, we know that this is the formula we're going to be using that relates these variables. So let's go ahead and differentiate respect to time. So once you get your formula straight, you can start taking the derivative respect to time. So that gives us, on the left side, derivative of s, that's 1. So it's just simply ds dt. Think of it as implicit differentiation. And then the derivative of pi d squared using power rule, that's 2 pi times d. But because it's implicit, we have to tag in dd dt. And you're looking for this quantity right here. So you simply divide by 2 pi d to both sides. So we have ds dt divided by 2 pi d is equal to d dt. Now let's substitute what these components are. So we know ds dt is 4, negative 4, d is 11, and plug this in. So you will have negative 9, I'm sorry, not 9, it's 4, divided by 2 pi times d, that's 11. And then if you simplify this, you will get negative 2 over 2, 11 pi, because the 2 cancels out. So that gives us 11 pi. That is the rate how the diameter is decreasing. So because it's negative, we know that the rate of the diameter is also decreasing. So you can imagine that the snowball is melting, its surface area is decreasing, so that the rate of the surface area is decreasing, so you know that the rate of the diameter would also decrease. It's getting smaller. So that's what the negative is for.